All right, so in this video, we're going to cover or document ADK Hybrid v2, but this is v1 structure. So far, we have connected Streamlit front end, everything local, to N8N locally at port 5678, and N8N then talked to our agent connection wrapper at port 8080, local host again, and this guy had the list of all the agents in the bundle, and it had the logic to redirect the request to the proper agent. And then our agent bundle sat on port 8000, and it was replying all the way to our Streamlit front end that we saw in the last video. All right, so besides all that connectivity, we also added a chat history manager using a SQLite database. Since this is a local host, it worked great. This was a proof of concept anyway, so we also enhanced our Streamlit front end using Supabase authentication and user management. So once we logged in and we started talking to multi-agent level, and also we logged out and logged back in and made sure that it actually remembered, all the chat history from before, because it was persisted on this SQLite DB. So all that being said, now that we are moving to the version 2, which will be everything will be resided in the Google Cloud. So what we found out was that this SQLite will no longer work because we're using Docker, and Docker doesn't have any persistence or anything. I even tried using Google storage and dumped the SQLite in there, still didn't work. So that's why we're gonna go talk about the v2 architecture next. All right, so this is the ADK Hybrid v2 2.0. We're going to go step by step. Our ultimate target is to, within this version 2, having everything on Google Cloud, right? But we're moving step by step. Like right now, only thing we moved to Google Cloud is this Postgres database, because we just replaced our SQLite with this SQL database. Everything else is the same. And another major change is we removed our N8N. N8N came in as a POC anyway. So now that we have established that we can bring in N8N anytime we like, so we just removed it for now. And plus, in this hybrid, N8N has its own place according to its own abilities. For example, N8N is great for connecting to third-party applications or services, and whenever we need that, that's when we're going to bring in N8N. Otherwise, we can just have our own front ends, the same front ends here, Postman and Streamlit for now. In the future, we'll have, once we make sure everything is good here, that's when we're going to fancy it up with Next.js front end, right? So for now, we're still talking to Supabase for authentication. Using those users, we're logging in to our Streamlit front end, and Streamlit front end then talking directly to agent connector wrapper. For that, we made necessary changes here. The agent connector, we made very subtle, small changes that we're going to go over soon, but nothing major. And we also actually made some changes in the bundles. Basically, what we did, we went beyond Vertex. We kept some of them Vertex, and some of them we used Open Router, so that we can use other third-party or open source models like DeepSeek, R1, and then OpenAI, GPT-5, Nano, etc., etc. We're still maintaining our agent context in the Google storage bucket. And as far as this Google SQL goes, let's see what it looks like. All right, so this is our ADK v2 session store database. It's in the Google. It's a Cloud SQL Postgres DB. If you can go here, you'll see this is the default one that Google creates once you have the whole thing set up, and then you go in and create your necessary database, ADK sessions in our case. And this is the overview here. We are running on 2 vCPUs and 8 GB of RAM and 10 GB storage. And as you can see, Postgres SQL 17.5 is the version. Now let's go back and go to the code, and we will run everything step by step, and then come back and discover what kind of tables, etc. are created here. That being said, let's get started. All right, so this is the ADK bundle view. This is the structure. This is V2 here, and everything is kept the same. The calculator agent, the calc agent, greeting agent, Jarvis, the product agent, and here start server. That's how we actually start the whole ADK service. And under utility, this context utils is getting our context data from Google Storage Bucket, and the GCS util is getting the instructions. Everything is the same like before, but the models has been changed in 2 of these, Jarvis and product agent, but we're going to get to that later. But for now, we're going to show the 2 new things that had to be brought in, which is this Cloud SQL proxy and this script start proxy. These 2 had to be started first because in order for us to code all our agents locally and at the same time be able to write to Google Cloud SQL, we had to bring in this, and we had to create this proxy, and we had to enable a public API, and we had to enable a public IP for our Google Cloud so that we could develop locally. But when everything is ready to go, we're gonna go ahead and use the private IP and upload our agent to the cloud. So let's go start up our proxy first, and then we'll come back and start this ADK bundle. All right, so since they're all in the same folder, so let's start the proxy first. And this is going to start up our database proxy for using this Cloud SQL proxy. So let's start this guy. Boom. Now it is listening on the local port and this local IP and this port. But the reason it's working is because when we configured our Cloud SQL, we took this box's IP, my current development local box's IP address, and added that in that public IP network of the Google Cloud database. So now using this proxy, we're going to connect to the cloud. So now let's go and start up our ADK server, and look, it's ready for connection, and you'll watch what happens when we start that up. Let's go back. Okay, so we are back here. Now let's start the server. Boom. Now this is starting our ADK bundle, and it's talking to our database session and started it all up, listening on port 8000 as you saw in the diagram. And now let's go look at this one, and now look, it was listening for new connection, and it actually now accepted the connection from our local ADK bundle. And now we are connected to the cloud database, which means this guy, sorry, multiple things going on. So we go here, this guy right here. So now what you saw, we just started up our ADK bundle, and it's using a proxy to connect to this Google Cloud storage, which is basically this guy right here. Now, before we go into this detail, let's go back. And now what we're going to do, let's go to the diagram. Let's see what's the next step. Okay, so now we're gonna have to turn this guy on, our agent wrapper. And once we are done with that, we're gonna start our Streamlit front end. So let's go do that. All right, so this is our wrapper. Let's see what this structure looks like. Okay, it has a very simple structure, just a simple main.py file. But this time we added config.py and config.json, which we will look at later. So right now, let's just start this guy up with Python main.py. Now, all right. So now we have our wrapper listening on port 8080. And now next we're going to go start our Streamlit. All right, so this is the structure for our chat system. Main file is just chat.py, but we do have pages, the mission controller, where we actually control our instruction set as shown in the last video. Here also you'll see, even though we're not going to do anything with it, but this time our Streamlit has a makeover. Basically, it will open up with a login logout box, right? Authentication box, and then it will make us log in using Supabase. And we're going to go ahead and start this up with the start chat.sh. So let's do that. And boom, it started up. So let's go see where it is. All right, so here we're gonna go ahead and log in. Okay, so here we go. It's talking to Supabase and got authenticated. And now we are back into our chat system. And let's start by talking to our greeting agent. We do have anyone we can pick from, but we're just gonna use this guy for testing right now. And I'm gonna start with, yo, guess who's back? Just to test if it remembers, because last time we did, I did give him my name. So let's see. Boom, there you go. It remembered my name. It clearly remembered from my other sessions my name, right? So this is a proof that memory is working. And let's go quickly do a check on the database in the cloud. Right here, boom. So this is our database store, and this is our ADK sessions database. And so I'll pull in all the sessions here and look at this last sessions recorded yesterday, right? So this session still kept open because our user ID is the same, and that's how it's remembering my name from yesterday. Because check the date today, it's the 18th September. And it is holding the session from 17th, so from yesterday. But before I go to the events, let me show you this user ID here. This is actually coming from the Supabase, this table here, the ADK N8N Hybrid profiles. So this is the user ID that Supabase generates when we register, and this is the unique ID that goes beyond your email address. This is what Supabase generates. So look at this number, D7DFC627, and it matches exactly. So we know that this is the user ID it's maintaining. This is the session it's maintaining. Now let's look at the events. Boom. All right, so this last two conversation, the user and the user asked a question, greeting agent answered back. And let's check the date and time here. Boom, there you go. September 18th, just like here. So this is the proof that we are talking to the cloud database and retrieving data and maintaining our session memory and long-term memory, which goes beyond the login logout. All right, so we are back, and this is the question I'm going to ask. Thanks, I'm from Atlanta, GA. And remember this, because I'm going to quiz you next. I'm saying this right now so that he remembers it, and once we do the agent changes, we can come back and test if the session memory lasts when we swap out agents. All right, so great, whatever. So now let's go to this guy right here. is the calc agent, and I'm gonna also ask him, okay, so what did I ask you for last time? Last time I asked him for pie chart creation. So let's see if he remembers it. All right, so looks like it remembered that I asked him about a pie chart making question. And this guy also supposed to be a calculation agent. So I'm gonna ask him the next time a complex math question to test his calculation abilities. All right, so this is the question I'm going to be asking, and this should be the result, 21.63 feet. So this way, if the answer is correct, we will know that he is using his calculator tool properly and giving me the result. So let's go for it. Oh, there you go, 21.63 feet. And here, that's exactly the correct answer. So we are done here. One last one I'm going to be testing is our product agent guy, and him I'll just simply ask, yo bro, what's my name and my city? Last time I shared those with him, and let's see what he comes up with. Boom, there you go. Look at that. Name, city, Atlanta, Georgia. So he remembered absolutely correctly. So at this point, we know that we are writing to the Cloud SQL and testing everything after relogging in and after switching agents. So they are maintaining agent by agent memory, session memory, and long-term memory, which actually lasts beyond the login logout, right? So one last time, let's go check the Cloud SQL to see our interactions are recorded. All right, so we are back at our Cloud SQL. So as you can see, this last interaction we had with our product agent, and let's go check the date here. It's October 4th, 2025, and right here, that's exactly what today's date is. And let's go back a little bit to track our last few ones with product agent, calc agent, and that's exactly what they are. And the date is exactly here. So this is the proof that we are writing to the right place, which is the Cloud SQL. And that being said, let's move to analyzing the code base. All right, so before we get to the code, I just wanted to explain what's happening here. We're making a request from Streamlit. Streamlit goes to our agent connection wrapper. Wrapper talks to our ADK bundle, and in this case, we have two separate connections to our our Google Cloud SQL. To set this up, I had to set this Cloud SQL two different network connections. One is private, where once we upload this bundle in the cloud, then it's going to use this private network connection to talk to our SQL cloud, so that no connection from outside will bother this, right? This is very secure, very fast. But that gives us a problem. The problem is when I am developing my agents and testing everything locally, it will not use this private connection to talk to Cloud SQL. So when I set it up, I had to set up with two connections, one public, one private. Private will kick in once it's uploaded to the cloud. Then the communication will be cloud to cloud. But right now, as I am developing in my local system, I had to create a local DB connection. I used this Cloud SQL proxy, where the connection bounces here and then goes to the Cloud SQL via the public GCS network, Google Cloud Service Network. So to demonstrate this, let's go back to the actual DB where I get to show you the two different connections enabled. All right, so this is the setup I was talking about. I have enabled the private connectivity, the private IP, and the public IP connectivity, both enabled. This one will not work locally when I'm testing and building, but this one will. And in order for this to work, I had to create a public network where I assigned only my local system's IP address. In the whole network, it had only one IP. So even though it's a public connectivity, it has only one IP whitelisted. So this is also pretty secure, so nobody else, without knowing my IP address, can connect to this SQL cloud. That's how I have this set up. Let's go back. So now let's go tackle them one by one. This is the ADK server running on port 8000 right now. And this is the code. Before I go check up on these agents, let's look at this proxy setup and the server setup. So let's go here. This is how the server is being started. So I'm just currently hiding this name and stuff, password, etc. But normally this is where your password, Postgres cloud password, will go. So I'm running it like ADK API server, then host, a port number, and session service, and this is where I'm listing the remote Postgres SQL server in the cloud and the password and everything right here. But this one, at this point, this one will talk to this proxy server right here. As you can see right here, the cloud SQL proxy, this is a binary file. So I had to launch this one with all the necessary information so that, by the way, this is the wrapper, ADK wrapper. So we're going to eventually put this up in the cloud too. And right now it's running on port 8080. But here is the start proxy.sh. This is the proxy. This is waiting to listen to from our ADK bundle. So what happens is, let me go back. So once this request comes to the ADK wrapper talks to our agent bundle. Agent bundle then looks for the local proxy, sends the request there, and uses the public GCS network to talk to SQL. So this is how the whole operation is running right now. Now let's go back and analyze the agents. All right, so now quickly let's go over all 4 agents one by one and finish this video. So this is the calc agent. Now here's the thing. This was my initial calculator agent where I was using the code executor, which is a built-in code executor given to us by Google ADK. But the problem with this one, this makes the agent memory fail, even though the tool works, but agent memory doesn't function when I use this. This is probably an ADK bug. I've already reported this. So what I had to do, I had to rewrite the whole thing. I disabled that, but I ended up writing the calculator tool manually. Then that same tool we're just calling like this. And that's how you actually saw in the example, it answered a very difficult math question. All right, so that's calc agent. And then a grading agent looks like this. And this time I'm no longer using var text. Like for example, here you saw that I was actually using Google var text for the models I needed, like this one, Gemini 2.5 Flash. But here I'm actually using Open Router and bringing in a GPT-5 Nano and calling it like that. And as usual, all my instruction sets are coming from PCS storage bucket. Get live instruction. This function is actually getting me this instruction live, right? And as you saw in our Streamlit front end, we can actually save them and change them live. And as soon as we do, our agent starts behaving accordingly. All right, so now let's look at Jarvis. And this is the, also another simple guy, but this one uses the default Google search tool. And here I am also using Vertex, and I'm bringing in the Gemini 2.5 Pro here. This is probably the best model they have right now. So this is what I'm testing with my default Google search. Other than that, the last but not least is my product guy. This is also another one of the open router models using Light LLM. At this point, I'm using Quen Plus 25728. Has been a pretty fantastic one, but the specialty of this guy is that even though this is a Quen, one of those Chinese models, most of those Chinese models, no matter how good they are, their context window is very, very small. But this guy, Quen Plus, actually has a million token context windows. That's why I'm using it. Also, this agent has this context tool, and using this context tool, this guy is actually fetching context from Google storage. So if we look at the fetch context, where is it? It's under utils, context, boom. So this is where they're actually bringing up all the context and reading from the Google storage bucket. And with that, to this video,